Hey everyone, welcome to this episode of Leading Innovation at Work, the Future of Business. I'm your host, Lorri Rowlandson. In today's episode, I'm really looking forward to hearing from Ceilidh Higgins. She's an interior design leader and senior associate at Custance. She's also a BIM specialist, and she's blogger at the Midnight Lunch. And I'm really looking forward to hearing more about your blog, Ceilidh. How are you today? Thank you so much for joining us.
Hi, Lorri. Thanks for the invitation to join in.
Hey, Ceilidh, just before we get started, I'm always so curious as to how people get into this profession. Obviously, when we were kids, the robots were on the Jetsons and cartoons, and we didn't have them around us. We weren't learning that in school. I'm really interested to hear, how did you end up in your current role? What do you do today? And how did you become interested in the topic you're speaking about today?
So, as you mentioned, I'm an interior designer and senior associate at Custance. We're a 12-person boutique architecture practice here in Sydney, Australia. So I studied architecture and I long had an interest in technology through, I guess, not a deliberate choice of career path, but just opportunities that were offered to me in the large practice I used to work for. I got the opportunity to learn Revit quite early on and get very involved in BIM and to attend an event called RTC, or it's now known as Built. And over the years, I've become a part of that community, a speaker, and now I'm part of the organising committee for that event, which operates around the world, here in Australia, New Zealand, over there in North America, Asia, and Europe. So it's, my partner jokes, it's my hobby that I do something related to my job on the side.
I love that. Well, this is my side gig, right? It's a great way to have like a little sandbox or a petri dish to experiment with and try things and have fun. Great network. So I love your passion, and obviously you take a personal interest in what we do as well, which is terrific.
Yeah, that's right. And I guess my blog has come out of that as well. It's a platform where I can research, write, think, and talk to other people about what's happening in the world of work and the world of architecture and design, where it's been an interesting couple of years where there's more and more intersections between technology and workplace design that probably 5-6 years ago people weren't really thinking in that space.
I think it just continues to accelerate. And, it allows us to really manage the space as a program, right? Once you have that type of intelligence and insight around the spaces, it allows you to have much more flexible, resilient spaces, on an ongoing basis once the initial design is done.
Absolutely.
Yeah, that's great. Well, I'm so excited to hear about your topic today, Ceilidh. So why don't you just take it away?
Thanks, Lorri. So today's presentation is called Will a Robot Take My Job? And I'll be talking about the impact of robots, computers and automation on architecture, design, property and the workplace. So we're starting to see robots quite commonly advertised for construction sites. If you Google bricklaying robots or construction site robots, you'll see a lot of videos that look like this. They make it look pretty clean, pretty efficient, pretty fast. And you have to think, well, robots are going to take over the construction site pretty quickly. But then not all of them are quite so speedy. This one is a drywall robot. And this one is a bit slower, but you can still see that there could be a lot of manpower savings on a construction site. So in countries where manpower is expensive, perhaps this kind of application could become reality, and obviously over time these kind of robots are going to get faster. But you could basically set this one to run for the weekend and everyone could go home and maybe the job would be done, depending how often it's charging. So we're seeing robots on construction sites, but what about other kinds of jobs? And what about particularly consultants working in the property industry? Obviously, as an interior designer and architect, I've got some interest in what will robots and automation have, what impact will they have on our jobs? And this is a topic that I've actually been researching and speaking on for about 5 years now. This quiz came out about 5 years ago on a UK innovation website called Nesta. The quiz is actually still there. They've changed the graphics a bit, but you can go and check it out. I can provide links to all the videos and sites mentioned in this presentation as well for people who are interested. So interestingly enough, it asks you about 5 questions, and the questions are to do with what kind of activities you undertake in your job. They're about how much problem solving you do, how much you talk to people, how much creativity there is in your job. And architects is one of the top jobs nominated as being automated. So at no point in doing this survey did I tell this computer that I was an architect. So this is like just a top idea. So it's probably pretty unlikely that architects, designers and other consultants are going to be replaced by a robot. But how about a computer? First though, let's have a look at the reality of a construction site robot before we worry about if we're going to be replaced.
So our system is called SAM, for Semi-Automated Mason, and developed by a company, Robotics. The SAM system is working alongside masons, helping them install brick. They can handle a wide variety of bricks that are used out there.
So as you can see, the humans haven't disappeared from the equation altogether. They're working with the robot, and this is likely the future for many, many jobs across all industries. It will be robots and computers working with humans. So we've actually already had a bit of an introduction to me. I'm a writer, speaker. I have been described by others as a thought leader and futurist, and as I mentioned, I'm on the build committee. You can find me tweeting at all 3 of those Twitter handles, the main one being at CRE Higgins. And then in my day job, interior design leader, senior associate, Revit user, and I am, as I mentioned, qualified as an architect. Today, what I'm going to talk about is based around 4 sections. So I'm going to talk about technology and what are some of the current technologies that are out there that are going to influence architecture and the property industry, but looking at some of the applications outside of the obvious. Then I'm going to talk a bit about practice and what people are actually doing right now, and some of the tools that are available now or up and coming over the next 12 months. Then I'd like to do a little bit of crystal gazing and look into what that could mean for the future and for the structure of the construction industry, the property industry, and consultancy practice. So, technology. Some of these will be familiar. Robots, obviously, we've just spoken about, have a wide range of potential applications. 3D printing is another really interesting one. This one is a construction application. This site is in Dubai, and it is the world's first 3D printed building. I went to a presentation by the project architect who worked on this project, and what is really interesting is you just think, oh yeah, 3D printed building, they just printed a building. But there's a lot of issues that have to be thought about. Basically, there are no codes, there are no standards, they don't know what materials to use, they don't know how to waterproof it. It's like almost starting a building from scratch. So there's a lot of development that really needs to happen before we can just go, oh, let's go 3D print a bunch of buildings. 3D printing also has some great applications in the medical field. This one is really interesting, where if someone has bone cancer, they can cut out a segment of the bone and they can actually replace it with a 3D printed custom implant. This technology is very real and very much happening right now. I actually finished earlier this year design of a laboratory, a research laboratory here in Sydney, where they are 3D printing human bones and other parts for science. Virtual reality. This one is pretty commonly known in the construction industry. People have, if not experienced it, they've come across it in terms of doing a walk through a building. But some of the other applications that could be used in HR, training and psychology are really interesting to me.
That was awesome.
This particular example looks at your emotional response.
I am saying my worst nightmare.
So by the end of this,
spikes at 132 beats per minute, almost twice a resting heart rate, and he hasn't even moved.
he's having an absolutely physical response to this emotional experience. He ends up shaking and sweating. So whilst it might be virtual, our response to virtual reality can be as real as if we're actually standing out there on that plane. So I think we're going to see a lot of really interesting applications for virtual reality over the next few years. Augmented reality is one that's probably best known, I think, for the Pokemon Go program, but again, has a lot more potential. There's a lot of furniture augmented reality I've been seeing lately where you can scan your living room and put some furniture in it. But this one that's come out from Microsoft just a couple of months ago at their conference is really interesting. Now, one thing I want to point out is that they did this demonstration live. So this is not a video that they have manipulated. It was a live demo.
Let me introduce you to Mini-Me. There she is, my perfect hologram. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Render keynote.
So one thing I'll point out before she starts speaking, this lady does not speak Japanese.
私たちは最新の複合現実キャプチャー技術を使用し、私のホログラムを作成しています。実在の人物をホログラムとして見たことがあるかもしれませんが、私が実際に日本語を話しているのが新しいのです。私は日本語を話しませんが、私の声とホログラムは完璧な日本語で話しています。これはニューラルテキスト読み上げと呼ばれる最新の人工知能技術、いわゆるニューラル TTS を使用しています。
Now, this is going to be game-changing technology potentially for the way we interact, the way we work. I don't think we're going to start suddenly seeing this in workplaces next year, but it's something that is potentially going to start to impact the workplace in a longer out time frame, and obviously dependent upon speed of technology and speed of internet and things like that. And another big one for the property and building industry is the Internet of Things. We're already been seeing massive developments in this space, in smart cities and smart buildings over the last 5 years. This has been a really big growth area. And this is a building in Europe which probably 2 or 3 years ago was the smartest building in the world. Perhaps there's a smarter one now. But it's interesting to look at all of the applications that sensors could be used for.
En daarnaast bestaat het uit een netwerk waarbij armaturen en sensoren zijn verbonden. Dus we hebben eigenlijk een digitaal smart ceiling gecreëerd. Nu hebben we sensoren erin zitten, sensoren voor bewegingsdetectie, voor daglichtregeling, voor temperatuuropmetingen. En daarnaast is het zo dat we andere soorten sensoren kunnen gaan plaatsen. En denk dan bijvoorbeeld aan luchtvochtigheid, CO2 en wat nog meer in ontwikkeling komt.
Wat voor Deloitte heel erg belangrijk is, dat we die data uit die systemen verzamelen. En met die data kunnen wij natuurlijk precies zien hoeveel werkplekken zijn we gebruikt. Hoeveel wordt er gebruik gemaakt van de vergaderzaal. Hoeveel mensen zijn er in het restaurant. Nou, dat soort dingen, al die data die zorgen voor meer comfort. Het eindgebruik helpen om het dag efficiënter in te richten. Maar uiteindelijk ook duurzaamheid. We kunnen daardoor het energiebesparing dan nog verder opvoeren.
So whether we're talking about sensors that are embedded in a building, sensors in a phone or in a badge, that enables us to collect a lot more data about how a building is used and opens up a whole lot of opportunities as to how occupants use space, as well as all the building services and sustainability identified in the video. Which leads us into big data, because you're collecting from those buildings potentially a mass of data. And then you have to think about, how do we analyze it, how do we use it, and what do we do with it? So the obvious use for big data is starting to look at algorithms. Algorithms basically can start to create a set of instructions for a task. So these can be as simple as a recipe or complex as a program. A pine cone is an algorithm. So we see algorithms all around us already. It doesn't just relate to complex computing, but essentially an algorithm is a form of problem solving. This building is designed from an algorithm and built by robots, and it's certainly something that we're going to see in the future. One of the next big terms that we come across is machine learning, and I think it's really hard, even for people sort of working in the tech space often, to understand what machine learning means and what a lot of these terms mean. There are so many of them and they're coming out every day. This video is actually just a really, really great and simple example of what machine learning is. So I'm going to let this one play.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter and find us on Facebook.
So one of the interesting things I think from that video is they mention a number of aspects of machine learning in industries where it's being used. And there's not a lot of applications there that would relate to property or construction. So I think there is going to be a lot of growth in that space. I do know that there are a few people starting to work in that area, but it's still very, very much, a handful of people in the world who are applying machine learning to problems in property and construction. Neural networks essentially is another kind of machine learning that more closely replicates the human brain. So that's really all you need to know about that. It's a computer system modelled on the human brain. So it learns more like we do. And then, of course, the other popular term of the minute is artificial intelligence. It's been quite interesting in recent years. Artificial intelligence has really been growing in terms of its use in the mainstream media. And there's been a lot of cases looking at how AI might work in creative industries. One of the funniest, which I love, is when they asked an AI to try and name paint colours. Some of my favourites here, I do like dogwood and Danky Bean and Turdley. That does actually seem to be quite an accurate name for the colour. So obviously the AI has kind of understood some of the premise of naming colours, but it hasn't understood the fact that they actually need to be attractive. And it doesn't understand that subtlety. But can AI design? So this is an interesting question. This is an AI called Ada, who is a fashion designer and an artist. And she is also a robot, obviously driven by an artificial intelligence. So if we start to say, well, if this level of creativity can be applied by artificial intelligence, why not see more artificial intelligence in building design? We're already seeing artificial intelligence in fashion design. This website, the dresses are designed by an AI, and then they get people to vote on which ones they like best to release as actual dresses available for purchase. And they actually support women in STEM as well, which is nice. So there's some of the current sort of terms and applications of technology that I think are probably the most commonly bandied about, both in the property industry and more generally in society, that I think we will see having impacts on work over the coming years. But what about right now? What's happening in design practices right now behind the scenes? So I think this quote by Thomas Edison really applies to design. So regardless of whether an AI can design or not, a lot of the work that we do in design consulting is really about problem solving, and it's about grunt work, and it's about documentation. And so I'd like to think that computers could help us reduce that amount of work to allow us to focus on the more inspiring parts of our design work. So you may have come across the term BIM, Building Information Management. So there are a lot of architecture practices who might suggest that because they use BIM, they are at the forefront of technology, they're doing automated design. But really, just because you're using a computer to produce drawings doesn't necessarily mean you're looking at information, which is really the key in these next phases of changing the way in which our industry works. It's about information, whether you call it an information model or a digital twin. The availability of information, both at the design stage and construction and into post-occupancy, is going to be a very influential part of what changes things. During the design stage, we can use information for analysis, commonly environmental analysis, but we're starting to see more forms of analysis taking place. The one I'm really interested in, which is very much a beginning area, is the analysis of workplaces and the analysis of layouts. Things like what Autodesk have been doing with their Toronto project, where they start to analyse and use computer algorithms to look at space, office space. And then that leads to the idea of simulation. Can we gather all this data? Can we analyse? Can we simulate what might happen in a real building once it's built, whether that building is a train station or an office? At the moment, we're actually quite good at simulating more simple building types like a train station, where people do behave in predictable manners. There's a lot of software that can actually predict how people will walk through a train station. But we don't have so much in the way of software that can predict how people will behave in an office, which I think is something that is going to be possible within probably the next 10 years. Algorithms and computers are obviously being used extensively in design, and examples like facade design are quite an obvious one. In fact, this facade, which is in Auckland, designed by Jasmax and BVN, uses a really simple algorithm. It's a chaos spreadsheet from Microsoft Excel, which creates a random manipulation of shapes. So using computers can be very simple in some instances. It doesn't necessarily have to be a complex programming language. So generative design is a term that we see a lot, and people start to relate that to certain kinds of looks, like parametric design. Does it look like a Zaha Hadid building? or other forms of kind of, because it looks like this, it's been generated by a computer. But really, the important thing about understanding generative design is it's about designers putting parameters, putting a brief into a computer and working with a computer to come up with options. And at the moment, it's very commonly used in things like structures, where you have a very clear set of rules around how a structure can operate, even one as complex as this, which is the water cube in Beijing for their Olympics a few years ago. Acoustics, again, it's a single problem where this is a bandstand and it's been designed to be optimized for acoustic performance. The thing is, when we come to workplace design, it's obviously a lot more complex because we're not looking at a single set of criteria, a single set of problems. Again, another simple sort of one outcome solution where this project they were looking at optimizing the amount of materials. So the architect had actually already designed this facade, probably with the help of a computer, but they then used an optimization process in order to reduce the amount of steelwork within that facade. And this one is starting to become more common and obviously opens up a lot of opportunities in terms of both design and sustainability. But one of the areas also that architects and designers and engineers are really starting to look at more and more is automation. And over the last couple of years, automation has certainly been a big growth area in practice. And I'm going to talk about that a bit more in the next section. So what are some of the tools that people are using to create these kind of structures and to undertake automation? So as I mentioned, BIM software is really commonly utilised, but there's a lot of different understandings of how automated that might be. So for someone who doesn't know the software, you might assume what I'm about to show you is what the software does as part of the package, but it's not. This is an additional add-in that you have to purchase and you have to have in your practice to help you set out amenities and things more quickly. So we're setting out bike stores, and then they start to set out toilets as well. So this isn't a base part of the BIM package. So it doesn't, just because this capability exists, doesn't mean that all architects and designers are making use of it. Some people are still laying out these things one by one. This is a similar example where, you know, normally you would dimension these columns one by one. Instead, by using a visual programming language, you can dimension everything at the click of a button. So these sorts of things, some people are using and some people are not. Now we start to get into more design-oriented tools. So this one is all about creating a lot of options. As I mentioned, structures and facades are one of the most common applications that we've seen historically of these kind of tools. And they let you generate a lot of options very quickly. None of these are necessarily ideal options though. It really is about potentially having hundreds or thousands of choices. And a human designer is still manipulating this and picking which choices they like. The next phase of that is design optimization. This is the video that's not going to work. So essentially, design optimization is like the example I talked about earlier with the material optimization of the facade. This example is a really, really basic one where they look at reducing the number of cut tiles on the roof surface. So for example, in a commercial office building, you might look at the ceiling grid or a toilet tile layout and look at how can we reduce the number of cut tiles by changing the setup point. So they're actually tending to solve, again, just simple individual problems, but they could be things that have a lot of impact in terms of cost, sustainability, and time on site. And they're not traditionally problems that designers have necessarily worked with either. They are problems that in the past would potentially have been left for a contractor to resolve. And I think that's a really interesting point about a lot of these technologies, is they start to blur the lines between who is actually responsible for this or that, and do I do something if the benefit and the cost benefit flows to the building contractor rather than to the design team. And that's something I'm going to touch on in the last section of this presentation in particular. Code checking is a great one. I think this is a really obvious place where we can start to automate design processes. This is a tool that checks your wheelchair accessibility. And it is set up, I believe, for North American rules. We don't use this one here in Australia because it's not set up for the Australian rule set.
Use classifications to identify accessible spaces and rooms. For example, an area of the ceiling panel can be separately modelled as the root. You can easily adjust the root parameters to set the root and door roots. Define also the components to be detected as obstacles in your route, such as doors and columns.
So what you see with these kind of things is there is a level of setup required. They have to have the local codes programmed into them, and then there may be setup that has to happen on the part of the designer. So it's not quite so simple as just build a model, click a button and run this tool. There is still a lot of process that goes behind that. And the other thing is there's a lot of financial investment that goes into buying all these different softwares and setting them up and getting them running. So over time, the intention is that they will pay off, but clients shouldn't expect that all of a sudden everything about design is going to be automated and it's going to cost them less to hire consultants. It's just, I guess, a different way of working, and hopefully one that results in less mistakes and less errors on site and less problems down the track. This one is a really interesting local example here in Australia, which is a property analysis tool. This actually starts to take development sites and look at their potential for development. And it pulls in all the local council codes and a lot of also financial data about sites as well. And they start to look at how many apartments you can fit onto a site, how many floors you could have, whether it's permitted for multi-residential development. And straight away, you can make all sorts of planning reports and developers can assess sites. I'm more interested in the next phase of the tool, which is actually going to start designing the layouts of apartments. But that one already is in the works elsewhere in the world. This is a European example, which is due for release next year. So basically, as they just pull and push the size of the apartment, the layout changes and adapts. Now this one is really interesting. This one is the one that probably most directly applies to workplace. This is a tool that's coming out shortly from Wework, and it's called Co-Designer. The intention of this tool is not that it's going to design workspaces replacing interior designers or architects, but it starts to provide another level of automation and assistance to the designer. So as I mentioned for some of the previous tools, there is a huge amount of setup. I've been to tutorials on this software. There's a huge amount of setup and background information that comes into play before you start generating all these design options. Based either upon data that can be gathered from other Wework tools or upon manual data entry. Basically, you start programming in your workplace brief, how many people you have, who needs to be next to whom, what level of collaboration they require, and it will then come up, you load in your floor plans, and it will come up with a series of scenarios. So potentially you could be looking at different buildings, as you're seeing here, or you could be looking at a number of options within one building. I think this tool will be a great tool for what we call here in Australia the test fit phase where clients are evaluating whether a building is going to suit their spatial needs. It's not going to replace interior design though, because it doesn't have that layer of, I guess, human consideration and looking exactly at what are the priorities within that workplace. You might come up with 100 or 10,000 options, but you still need to decide which is more important to you. Is it noise that's more important, or is it interaction, and is it different things for different teams? Another interesting point is that Wework are actually going to be selling this as a subscription service. So it's not just for people buying Wework furniture, they are essentially becoming a software company. So these are some similar examples which relate to whole building design. So this one, again, great name, it's called Test Fit. So
in a world where drawing site plans takes forever, on sites that will never turn into real estate development opportunities, there is a software to come to the rescue, kill deals using Test Fit.
So again, we see that this is actually probably targeted at developers rather than designers.
Easily swap building types.
And you have to agree they're pretty ugly buildings, and you're still going to need an architect.
Generate more schemes than a human mind can even think of.
But they can start to give you an understanding of the site's massing capability and the feasibility of a project.
Dive head first into urban planning. Hot swap different unit styles. Tap into the power of customization.
So they do start to offer opportunities to get a bit more involved in the design. But I think
Generated stairs, units, elevators, and custom locations.
it really is more about figuring out what you can fit on the site.
Not a fan of generative design? Customize your building massing.
And what impacts that has in terms of code compliance, building heights, setbacks, amount of gross floor area, those sorts of things. Car parks in particular, obviously, really, again,
stalls for you.
They're a code-driven kind of design, and it can be better done by a computer than a human being. This is another very similar example, design a building in under 2 minutes. I think probably this kind of tagline isn't the best.
Today I'm going to show you how to create a BIM model for your project in under 2 minutes.
This one is interesting because it actually starts to look at construction methodologies.
Select the frame type.
So I think this one's designed for
the height between the floors.
estimators, so they can start to cost the building.
You are then brought to an interactive map where you can search your desired site location.
So essentially from here, it's actually quite similar to the last example. So I don't think you could say that many of those softwares are actually going to start to replace architects and designers and are going to take over the whole role of consultants in practice today. They certainly are going to replace a lot of the, as I said, the grunt work, the calculations, the kind of amount of time we spend creating things like fire stairs or toilets to code, car parks to code. I think there's really big opportunities in terms of ensuring we have code compliant designs. And there's opportunities of understanding what the site advantages and constraints are, or the building advantages and constraints for an interior project. But what could that mean for the future of the industry, for design, for the construction industry, for property? So we are starting to see increasing complexity in the problems that these computers are looking to solve, going from a simple problem like just an acoustic solution, which was sort of a 5 years ago problem, up to looking at whole buildings that we're looking at now. some years ago, there was a company called Flux that was doing similar things to what we're actually seeing today as real products with apartment designs and building layouts. And they had the idea that basically a building could be created from a seed. The way that a tree is created from a seed, it adapts to all of its site conditions, and every tree comes from the same seed but becomes a different tree. Flux never took that program to market. They actually took to market an alternative information sharing program platform, which actually they shut down as well. And they felt that basically the industry wasn't ready for an end-to-end data sharing solution. And this is actually a conversation I have quite frequently with friends and colleagues who are working in the tech side of design. Is every aspect of our industry, from design through construction, through to facilities managers, owners, occupiers, we might be able to offer this ridiculously detailed model, but is anyone actually ready to use it? Do we have the software in place? It's almost like it's actually too complex, and people have to be ready for that level of technological change. So, and the same applies actually to a lot of these generative design programs that we're seeing come out. These are all last 12 months. The capability, the technical capability has existed for 5 to 10 years, and we're only actually seeing products coming to market in the last 12 months. And I think that's because there is now a wider acceptance of the use of computers as a design tool, as we start to, I suppose, go further and start talking about artificial intelligence. The idea of computer designing a floor plan becomes a little bit less scary. But construction still lags massively in terms of productivity, and it's actually getting worse, not better. It also lags massively in terms of spending on information and information technology. It's one of the lowest spending industries, and this has come across so many different surveys. Like, I could probably find half a dozen different sources that say construction is either the lowest or the second lowest in terms of spending as a percentage of revenue. And it's really something I think that is going to have to change for technology to have an impact on our industry. And it's the only thing that's going to actually help the productivity, I think, is to actually look at implementing that gap. So right now, according to McKinsey, there is a $1.63 trillion productivity gap in the construction industry. So it's not surprising that we're starting to get more and more companies look towards construction. I've talked though before about, in my blog, I've written a lot about why we haven't seen innovative disruptors in construction. And part of the issue is, unlike all these companies, is construction on the big end of town, it's not a consumer Bible. It's not going to change because, you know, millions, billions of consumers start buying differently. It has to change at a larger level. You can't just suddenly start selling office buildings to individual consumers. And at the moment, the way that we procure buildings across the world is a really broken up process. It is like, you know, a typical office block project. I think, you know, you have 20, 30 different consultants. You then have 20 or 30, 50 different subcontractors underneath your main general contractor. And then off to the side, you have facilities managers, project managers, clients, and then the tenants. So there's just so many people involved. So how could construction change? Well, potentially, I think it's going to change through the involvement of larger companies, larger potentially software or logistics-based companies. And they are starting to make a variety of interesting moves into that space. So Amazon right now, they offer a flat pack cabin that you can build in your backyard. Okay, it's not about to start competing with architects who are building 30-story commercial towers, but perhaps that's just the beginning. Ikea have taken that step a bit further. They have actually partnered with an architect and are developing an infill flat pack solution called the Ikea Urban Village. I think some of these are about to be built in the UK as seniors living. Airbnb have started to make their way into the construction sector. Their approach seems to be a bit different though. This is a one-off community centre and Airbnb in a small town in Japan. So it's not clear how Airbnb might end up involving themselves in design and construction, but obviously they've started to dip their toe in the water there. Google Sidewalk Labs is a very interesting project. So this is based where you are, Lorri, in Toronto. There's a waterfront site which I think they were looking at developing something over 100 hectares as a technology and living hub, and now that has been reduced to a 12-hectare site because there was a lot of concerns over security, privacy and gathering data, and they're now under quite strict rules, but I believe the project is going to go ahead. There are some interesting aspects to the project other than the smart city and all the data they're looking to collect. They're also looking at quite innovative construction techniques with a lot of prefabrication from glue laminated timber. And almost all the promotional images are these hand-drawn sketches to try and make it look like it's not technological at all, which I find interesting. So that's certainly one to watch. Another interesting example is Wework. Now, when I first put this presentation together, Wework's IPO hadn't gone down the drain, but I still think Wework is an interesting example of what could happen if we start to look at construction and property differently. So one of the things about Wework is that typically they design, own and operate their spaces. So while they lease the actual floor plate area, they own the fit out and they're responsible for maintaining it. And so that means they can start to really look at how they optimize things. They've been criticised for optimizing and using, very new design techniques for a very old problem. How many desks can we fit into a room? But the fact is that a large proportion of us still spend our days sitting at desks, and when people are looking at renting space in Wework, they want to maximise the number of desks that they fit into their little box of space. And this is obviously a design problem, that because Wework do this kind of repetitive design every day, it's worth their while investing in this kind of problem. They've also looked to invest though in problems that cross from design to construction. For example, optimising the layouts of the aluminium framed fronts to meeting rooms and offices. So they have a tool that their design team will use, which will lay out all the panels and everything exactly as it will be constructed. Now, I'd love to have that tool in my office, but I don't build the shop fronts. So it's not worth the while that I would have to spend investing in building that tool to have that advantage. So the fact that Wework then occupy this bunch of spaces that operate in a similar way has also allowed them to do some amazing work in terms of occupancy and what happens post-occupancy, and then feeding that back into design. One of the interesting things about the Wework model is they employ a lot of really amazing architects and technical gurus. There's a lot of really amazing researchers and programmers have been working there over the last few years, and they've really invested in technology in a big way. So they gather a lot of data from their meeting rooms about everything from whether people like the decor to whether the whiteboard is working to how many people were actually in the meeting. So some of this data is obviously used for immediate things like there was no pens in the room, we need to fix this as a maintenance request. But some of the other data, like the number of people in the room, is starting to be used for design. So they have been using an artificial intelligence to look at the size of their offices and the number of meeting rooms that they need and how heavily utilised they are, and essentially to analyse that
And what is interesting is the prediction by the computer is much closer to the actual outcomes of meeting room usage than the predictions by the designers. So the designers aren't bad, they're all sort of roughly around the line, but you can see that the computers are sitting much closer to the line. So that is really valuable knowledge to make sure that you're maximising the use of your meeting rooms, providing the right mix of sizes, and getting the best use out of your space. And this is sort of getting back to what I was talking in the beginning about starting to look at how can we simulate the actual use of office space. So I'd like to think that these kind of technologies will help us, and that technology will become an assistant, a tool, more and more for designers, for clients, for building owners, to help us make smart decisions, to make decisions based upon real statistics and data and not just our gut feel. Often our instincts are right, but often they're really wrong as well. A lot of the studies that come out of the Humanize data badges tell us that what we think instinctively might work in terms of collaboration and people interacting with each other isn't always what actually works in reality. One of the things that really is important, I think, as well, is for people at all levels of an organisation to understand that technology and automation are not coming, they're here already, and they're affecting different industries at different rates. But you want to be making the most of it, whatever role you're in, and you don't want people automating their jobs and not telling you. You want to actually have them automate more once they've done that. I'd like to think that these kind of technologies might open up new opportunities in design. And one thing that I've long speculated is, what if beauty is an algorithm? What if by using computer algorithms over growing complexity, we can actually start to design more and more amazing buildings, like here the Sydney Opera House, because we can actually maybe start to analyse and understand what factors it is that come together. I don't know that this is a short-term goal, but perhaps a much longer-term goal of understanding architecture and design and how people actually use and inhabit spaces and what makes them feel like this is a great space to work in, to be in, to do things in. And so I hope you found that introduction to the world of technology through an architect and design perspective interesting. And if you have any questions, Lorri, I'm quite happy to answer some now.
Oh, thank you so much, Ceilidh. That was an absolutely incredible buffet of technology in real estate. I love the diversity of examples you shared. But you know what, Ceilidh, one thing I particularly appreciate is we're dealing with disruption and innovation and futuristic topics. You actually took the time to point out specific examples and specific instances that really help people wrap their mind around an applied example and really help them move forward. So I really thank you for helping to take something that sounds so futuristic and show such practical examples. We've got an expression called practical innovation. So that really resonates so well with me, and I'm sure it does the audience. Just a couple of things I just wanted to underline, and I do have a couple of questions for you. Just as an aside, I love that robot at the beginning with the drywall. I know not too fast, but if you've ever lifted a sheet of drywall, especially on the ceiling, and tried to hold it up there, I need one of those robots. That was great. But you know, I think one of the other things I love about your message is that we have a fear of change and the unknown. And this has existed alongside human history. And I'm writing a separate blog on this now, but I'll just give you a few examples. You know, when the car was invented, humans were outraged that, you know, it would completely destroy industry. And we had an industry of blacksmiths and stables and things like that. And, you know, when the ATM came along and online banking, we were worried it would devastate banking. And same online shopping and retail. Now, mind you, it's changing, but I love what you say around working alongside technology and it being there to augment what we are doing, not compete or replace. what it will do is, instead of me laying drywall or whatever that version of it is, I'll be able to turn my brain towards other problems and other things. And, you know, I think the best intelligence we have is not artificial. And so just because we've had to do things in the past doesn't mean we have to do them in the future. And I believe in human progress, and it will free ourselves up from administrative or menial things that we can continue to flex our creativity and our ingenuity and a lot of things that technology can only mimic. It's our minds that can really develop that. We are clearly way better at naming paint chips than robots are, and I think we will continue to be. Another message I just want to underline before I get into questions is, I loved what you said in some of the specific examples. There were several, but one was around Hayworth. And you think of Hayworth as a furniture company, maybe around some design, but they are really becoming a technology company. You would never have thought of that. But I read a quote the other day that said, every single company, regardless of your core business, must become a technology company. And I think a lot
of people, a big one in technology circles, we see that all the time.
Exactly. And like, look at Wework. If you look at Wework, yeah, they're into the hospitality business, but it's clearly driven by technology. That's how they drive efficiency. That's how they drive a great experience. So anyway, all of that to bless you, my dear. All of that to summarize, I just really loved your message. So, okay, here's my question. That was a setup for this question. So many different technologies. What do you think is going to have the greatest impact on us soonest?
I think it is the generative design tools, whether that's for workplace like Hayworth's tool or the apartment design tools. As I mentioned, they are really, every single example I showed there, something new in the last 12 months or coming out in the next 12 months. And we're just going to start seeing more and more of them, whether they're optimized for different markets or different building sectors. You can absolutely see how that could apply to healthcare or aged care and seniors living, all sorts of schools, all sorts of different scenarios where their first basis of design is very rules-based and very much could be programmed. So I think that one is going to be a big area over the next couple of years.
And any other big theme, like you talked about things in categories as well. That's a good specific example, but categorically, you know, artificial intelligence, virtual reality, etc. Is there a category that you see is going to really be the most prevalent, 3D printing, whatever it is, really move the needle in the next 3 years?
That's interesting. I think probably virtual reality is the furthest developed with the most broad applications. I think that's the one that probably will impact more people outside of a technologist kind of a role. Like, we are seeing a lot of technologists now working in artificial intelligence and machine learning, but at the end of the day, most people don't realise. They don't realise that their credit card fraud's been detected because of a machine learning. They get an automated phone call from the bank. So there's a level of automation there, but they're not aware of the background of the machine learning. Whereas I think virtual reality is going to start to be used more and more. We're going to see it in training and psychology type applications, as well as in construction and property. And I think that's one that people will be more and more interacting with on a daily basis.
I agree with you, by the way. It's interesting because not many people answer it the same way you did. Two other examples that I agree with you, I think will affect the built environment is retail. I think I'm seeing a lot of virtual reality being tied into retail experience. And then the second one is around virtual reality for meetings. And you had the hologram example of that woman speaking Japanese. But with the adoption of 5G, it's going to allow for more virtual meetings. And what's that going to do for office spaces? I mean, if somebody's sitting on a different floor in the same building and they're still on the phone, you can be in different cities. So I'm really interested with the adoption of 5G to see how that's going to affect those types of real estate assets as well.
We have to wait for that a bit longer here.
Yeah. Okay.
I'm sure we're getting our 5G.
Yeah. it's coming. It won't be too far away. And then I think it's just going to create a huge explosion of adoption and unleashing the potential of a whole bunch of technologies, virtual reality being one of them. So, you know, I mean, we've been hearing about these different disruptive technologies or innovations for quite a number of years. And I'm wondering what you observe is what's holding us back? Like, why are we moving faster? I mean, we want this, it sounds cool, it drives great results, a great experience. Why are we moving faster than we are towards adopting some of these? What's holding us back?
I think there's probably two parts. One is, as you've touched on, the general human resistance to change into new technology. And I think that the technology is moving ahead faster than people are sort of ready to deal with. And then I think particularly in construction, as I touched on before, the fragmented nature of building a building and the number of different parties involved and where the benefits flow. Like, it's hard for us sometimes as designers to justify expenditure in a certain area of technology if it's not going to actually pay off for us, because we can't necessarily gain that profit or, you know, money back. Whereas a company like Wework, they have more of the cycle, and so they're able to actually realise more of the benefits, I think, because a lot of these technologies are not just about design, but they more tie together different stages, whether it's design and construction or whether it's design through to facilities management. And I don't think we've found the answers as to what those optimized kind of processes are that work for all parties. And the nature of construction contracts and the very sort of aggressive contractual nature of our industry certainly doesn't help with these new kind of ways of working that require more collaboration.
Yeah. I want to ask you a derivative of that. It's a very good point. I think it's easier if you have a new build, right? But one of the things I worry about, Ceilidh, is we can't treat our existing buildings like stranded assets. And those are the buildings that need to be retrofitted and improved and, you know, with efficiency, whether it be IoT or energy, some sort of an efficiency that's driven by technology. Who do you see that's investing in this? Is it property owners, occupants, facilities managers? Like, who do you see is taking the lead in retrofitting these buildings with different types of technologies?
And again, I think it becomes a really difficult situation. I certainly see in Australia that the leading projects in terms of innovation and sustainability are new builds as opposed to retrofits. We have a lot of existing building stock, and it's something I actually particularly work on myself. I'm currently working on a refurbishment of a 23-storey commercial tower, but we don't see as much investment by the building owners in the existing building stock as you would see in the new builds. And again, it's because the benefits of the investment, you know, they don't necessarily accrue, because some of the benefits will go to the tenants, some of the benefits will go to the owner. Like the owner might invest in something like upgrading all the lighting, and eventually it's the tenants that largely benefit from that because they're the ones paying the electricity bills. I think governments really need to step up. Certainly we see here that when government introduces minimum requirements, say around energy rating, then you get better results with existing buildings. But it's really interesting because what I see is that existing building owners are generally not trying to compete with the new buildings. They are typically seeing, well, that's a premium grade of new building and our building is going to sit below that. And they are often accepting of that, whether that's the right advice that they're getting from leasing agents and things, it's hard to say.
Ceilidh, thank you so much. I feel like in the last hour we packed in so much. I just feel like I've been drinking from the fire hose of knowledge. So thank you so much. And I love the specifics. I love how practical your advice is. Ceilidh Higgins from Custance. Please go check out her blog, themidnightlunch.com, if you haven't already, and follow her in social media. That's it for this episode of Leading Innovation at Work. This is Lorri Rowlandson signing off for now. I hope this information has served you and provided you a few practical tips to help you go out and lead change and make a difference in our industry today.